Great. All right. So thanks, everybody. It's Mike Scholand here again from CLASP. And thank you all for joining us for this training session on the energy efficiency testing of computers and the GTD software tool. I just wanted to say a few words as we get started here. My colleague Jenny Mandel is with me on the line, and she and I will be handling the questions and answers. And if you have any technical problems with your connection, with sound or video, you can reach out to us. You'll see a Q&A button at the bottom of your screen for the Zoom tool, and we encourage you to use that. We also encourage you to use that during the presentation itself. So there will be opportunities, there will be little breaks in the content, and at the end we'll have little short sessions to address any clarifying Q&A that come through. And then we'll have a discussion session with more in-depth questions and answers at the end. And there's also a raise hand function. So I think the best is probably to use the question to put your questions in, and then what we'll do is unmute you so that you're able to then ask your question and have a dialogue. We'd rather have the questions and answers verbalized, because this session is being recorded. And so anyone who's missing this session and wants to catch up later, it'll be easier for them to hear the questions and answers in real time than to read the notes that accompany that. So let me go ahead and get started. Just a brief word about CLASP. CLASP, we are a US nonprofit, non-governmental organization. We work on standards and labeling activities around the world. Myself and my colleague Marie Baton work for CLASP here in Europe, and we have been involved in the eco-design and energy labeling program for about 10 years now. We have our headquarters in Washington, DC. We have offices in Nairobi, Kenya, in Delhi, in India, and we're opening new offices now in Jakarta and in Beijing. So we're expanding and reaching out to new markets and trying to promote efficiency where we can. So this activity on computer testing came to us. We kicked it off just over a year ago. For those of you who attended the session last week, Paolo Tesserati gave a very nice introduction to the session. And one of the activities we've been working on for the last year quite closely with GTD and Intertech was to develop this software testing tool. And let me just go to the next slide here. So I have just two slides to show you before I hand over to GTD, who will be doing most of the work today, presenting the tool. These are the agendas for this week and for the second agenda we have on the 3rd of February. So today's session is 2 hours long. We're going to be starting out by discussing the tool architecture, so setting the context for how the tool is laid out, giving a little bit more detail than we have in previous presentations. For example, the one that was given last week. There will be a test setup and procedure, and then there'll be a 5-minute Q&A at the end of that. So if you had any questions at that point on the architecture or the planning, the strategy behind the tool, you can ask it then. There'll then be some discussion on the test setup and procedure in terms of how everything is connected, the unit under test, the controlling computer, how the data collection is done. And we actually have for you today a live demonstration. So Thomas and Yuan are in their office in Germany, and they have a camera, and they will be showing you the setup. And then we'll actually be running a test in real time. So you'll be able to see that, which is pretty exciting. And then there'll be some discussion at 4 o'clock on the worklets themselves, the logic behind the worklets, the idea of not reinventing the wheel, but actually using tools that are there, that are representative of real life, of how people use their computers and their work. Tool analytics and worklet scores, so the output from the tool, comparison, and then some comparisons to other benchmarking, industry benchmarking tools like Sysmark and PCMark. So, and then we have 20 minutes at the end for Q&A. So that will be where we go into in-depth questions. But basically, after each of these sessions, there will be a little break if there's any clarifying questions you want to ask before we move on. So please use your raise hand function or Q&A, and Jenny and I will moderate that. And again, any problems with sound or video, let us know. And then in 2 weeks' time, there will be a second session which will go into more depth on the tool. So this will include looking at the worklets themselves, changing, modifying the worklet set that's run by the tool. So that could include changing the worklet characteristics, adding or removing worklets, changing the number of times that they run, and so on. So that's going to be the kickoff. Then there'll be a discussion on worklet selection. So the sort of rationale behind selecting a general set of worklets that could create a categorization for the A to G energy label, and an additional set of worklets to look at the performance in different categories, the possibility of doing that. So is this computer designed, for example, for office use, for gaming, or for video and editing of media? And then finally, this third section of the second session is going to look at the final results, the aggregation method that's used, the analysis behind that, including the performance, power and energy, and the output file. So there's now a sort of more detailed Excel file that's produced, so you can run and do additional plots with the output if you wish. And again, Q&A at the end. So there's a hyperlink here. Jenny or I will drop this hyperlink into the chat for this session. So you'll be able to if you haven't already registered for session number 2 and you'd like to, you'll be able to grab that today. But we will also be sharing this when we share the slides from today's session with everyone. Okay, so that is it for me. I'm going to stop sharing now. Thomas and Yuan, are you able to jump in?
Yes, hello, Michael. Thank you for your introduction. Yes, now I will share my screen. So there you are, I think.
Yep, can see that.
Okay, so my name is Joan Roig. I'm at GTD's office today with my colleague Thomas Bucha, and we will present you the software that we've been making during the last month. Let me just very briefly introduce our company. We are a small company that works on the aerospace sector, mainly for the European Space Agency or the German Space Agency. We were grounded in 2013, and we are located in the south of Germany. We are the German office of our biggest Spanish firma, which is also called GTD, since 1987. Which also mainly works in the aerospace sector. But as you can see here, we also work for other domains like what we are presenting you today. Our agenda for today is just mainly showing you the architecture of the test tool that has been developed, the setup and procedure. So what do you need to run it and how to prepare everything to run our test. And at the end, we will also present you an analysis of all the worklets. I will explain later what a worklet is. So an analysis of the worklets we have included in our test suite. So if we just start with the architecture of the tool, our tool is based on an already existing open source suite, which is called Phoronix Test Suite. It is important that it is open source because it lets us use it, freely use it and modify it to our needs. This tool runs a series of worklets. Being a worklet, as you can see at the bottom of the slide, is just a set of tasks that we place together in a workflow. So it means that there is a sequence of activities that we can easily reproduce. This is very important because we want to reproduce all the same tests in the same way in all the computers we are testing. So with this, we haven't made up this word worklet. You can find some references on the internet, but it's a concept which is very useful to discriminate our test, to just letting us organize all what we have in a different set of activities. This Phoronix test suite executes its native binaries on many operating systems. At this point, we are running them in Microsoft Windows, Mac OS, and Linux. This is very important. We want to have native binaries. We don't want to have some kind of virtualization or whatever to be able to run the worklets. Why? Because we want to reproduce the user experience on the computer. We don't want to have additional software that could change the performance or the power demand of a computer in an unwanted way. We want to reproduce the user experience. And this is why we have native binaries and we use them. It is important also to note that measuring the power demanded by the computer while we are running the test does not alter in any way its performance or its power demand. And this is important because we don't want our measurement software to change the way the computer behaves. We want it to normally behave while we are collecting power measurements and all the data we need to give efficiency and performance measurement of the tested computer. And at the end, this test suite also provides a way or provides a single result. We don't want, or we have, in fact, during the execution, we have results, efficiency and performance results for all the worklets we are running. But at the end, we want to obtain an efficiency metric, a single efficiency metric. And this is what the software does. It fuses all the results together so that at the end, we have a single efficiency value. The Phoronix test suite, which our software is based on. So as said, it is an open source framework. It can run natively on Windows, Linux, Mac OS. It has been written in PHP. And this suite automates all the testing process, meaning that once you start a test, no more user interaction is required. There are a lot of predefined test profile, let's say, or call it worklets, and we don't use all of them. For our test suite, we have selected the ones that we have considered the most significant ones for the purposes of our testing. But in any case, there are many worklets or test profiles available for this test suite. One important thing is that it is easily extensible. So being it open source and knowing that they provide a lot of documentation, you can extend this test suite to adapt it to your needs. And this is what we have done. And this is one of the reasons why we have chosen this framework. This framework also provides a result viewer, meaning that you don't need any additional software to just analyze the results provided by the test suite. But in any case, if you have your own tool and you are not happy with the result viewer and you prefer to use whatever you have, you can take as an input also a CSV file, which is also provided by the test suite. So you can view your results either in the test suite viewer or just by using the exported CSV file. One additional characteristic of this framework is that it provides support for power measurement devices. This is very important to us. We want to measure the power demand of the computer, so we need a tool that is capable of interacting with power measurement devices. And Fronics Test Suite provides this. And also important is that it can run offline. You don't need an internet or any kind of external connection to run all the worklets once you have installed everything on the computer. And this is important because when a computer is connected to the internet, you don't know what the operating system can do in the background at a very specific moment. Maybe while you are running your test, the operating system decides to update or get updated or whatever, and you don't want that. So this is why it is important to us that there is no external connection. So we've made some changes to the Fronics Test Suite to adapt it to our needs. I told you that the results all the results are merged in a single value. So we added this support for merging the power data after running all the tests. We have also improved the way in which those tests where a lower value means a better result. So yeah, we have improved this calculating because there are in some tests a higher value means a better result. In some others, a lower value means a better result, and all of them have to be properly merged into the final result. There were some little aspects that didn't work very, very well on Microsoft Windows, like the support for power measurements or the result viewer itself. So we have improved such that they perfectly work on Windows the same way that on Linux and macOS. We've also made the installation of PHP robust on the Windows. We've improved the way the output CSV files are generated to give the end user more information and more details on how the execution of the worklets perform. And we've also done some bug fixes and optimizations. Each worklet is just defined by the following aspects. So each worklet contains a test definition. So what is this worklet testing? A result definition. So what are the results of these worklets and how then have to be analyzed? A download definition. This is mostly for the installation part because some of the worklets may need additional dependencies, additional software. So this is defined in the worklet to know what is required to run it. And then also, of course, each worklet has an installation script that has only to be run once, and a run script, which is executed every time you just run the test suite. All definition files are written in XML scripts, shell script files. In today's webinar, we won't, in principle, we don't plan to show them because this is planned for the second webinar in 2 weeks. But at least you know that these files exist. And for a normal test run, they are not intended to be modified by the user. A test suite is just simple. Our test suite is just a series of worklets and the configuration of options for each worklet. In a normal run, the user doesn't have to configure them manually. They are pre-configured for our needs. Another important aspect is gathering the power measurements. So we use a signal analysis tool, which is open source and is called Citroc, that acts as our driver to connect the power meters to our test suite. This software is cross-platform, like for an test suite, so we can use it in the three supported operating systems. It's vendor independent, so this is good. It doesn't depend. It supports the devices for any of the manufacturers you can imagine. So, and although this is devoted to be used with any kind of power meter, there are minor tailorings that we have to do. So at this moment, we have support for the 3 Yokohama power meters that you see here in the slide, and the 2 Hioki ones. In principle, as far as we know, many of the computer laboratories do have one of these power meters. But in any case, the software can always be extended to add support for more power meters. What I have told you up to now is for power meters connected via USB interface. If your power meter has a GPIB interface, then instead of using the SIGROC driver, you have to use a Python application that has been specifically created for this purpose. Later during this presentation, you will see that we have 2 computers, not only one. The computer in which we are running the test and the computer which collects the power measurements from the power meter. This computer is what we call controller computer. And in this computer, we run the following software. So PHP, because for instance, suite is developed in PHP. We run the presented driver for the USB connected power meter. It also runs an NTP server because it's very important to synchronize the times between both computers. And also the test, the Forerunner test suite configuration, because we provide the Forerunner test suite result viewer in this computer. On the other side, the UUT, which is the unit under test, is the computer in which we are the computer that we are actually testing. So it also runs PHP and its dependencies. In this case, also an NTP client to synchronize the time of this computer with that of the controller PC. Of course, third-party applications used for the worklets are required, like Firefox, LibreOffice, GIMP, and some others. But you don't have to install them manually, as we will see. So there's no need to worry to install individual packages or applications. Also, Cygwin on Windows to run the worklet script, and then, of course, for its test suite and its configuration, and all the relevant worklets according to the definition files that have been provided. There is also a user interface that we will see later, which has been written in Python using the standard Python GUI toolkit. And in fact, this user interface is just a front end for all the scripts that are run behind, let's say. What I mean by scripts? Well, in fact, we could launch all of the characteristics of the test suite via the command line interface. There is a set of scripts that are not intended to be manually launched by the user. This is why we have the graphical user interface. But in any case, there is this set of scripts that each of them individually runs one of the aspects of the test suite. So there's a script to install the software on any of the computers, an important one to check that the controller computer is correctly connected to the power meter. Then there's a script to run the benchmark, another one for a short benchmark in case just you want to briefly test the behavior of the test suite on your unit under test. Of course, the script to open and to run and open the result viewer, and then additional scripts to run for only test suite commands, the script to start the acquisition of power meters, synchronize the clocks on both computers. either between them or synchronizing using an internet server, and of course the script to uninstall the software and update the test suite once you already have it installed, but an update has been provided by us. Okay, so this finishes the first part of our presentation. I don't know if there are any questions or...
Thanks, Johan. Yes, there was one question which got asked, and I gave a short answer in the narrative, but would ask you guys to address it now. Noah Horowitz from NRDC wanted to know, will the worklets work on Google Chromebooks, on Chrome OS? Could you respond to that point, please?
We have received 2 Google Chromebooks actually from Google. Thanks for that. So we can actually do some testing here. And our findings so far are that the Google Chromebooks actually provide a virtual machine which runs Linux, which is officially supported and promoted by Google. So this could be one option to run the worklets basically unmodified in the Linux version we have right now. And we expect that around 35 of our 46 worklets would work without any modifications. The remaining worklets are the graphically intensive ones. Those are usually not very useful in virtual machines because you don't have 3D acceleration and stuff like that. Apart from that, Chrome OS itself is also a Linux. It's based on Gentoo as far as I know. And it can be switched into a developer modus where you can actually install new software natively. So this could also be an option to run the worklets natively without the VM. But of course, this is then a bit more work and also does involve actions which are not necessarily representable or representative of what a user might be doing with that device, because I expect most users will not switch their device to development mode and install arbitrary software. So Chrome OS, it's a bit tricky, but we see a way forward, or basically 2 ways forward to make it work on those devices too.
Great, thanks, Thomas. Could you guys address the next question here? Peggy Tang has asked. Oh, sorry. Just a note here. I see several people in the attendees list have logged in as Raphael. So I'm guessing what happened is Raphael registered and then shared her login link with several members. If you would like, you can rename yourself in the participants list. You click on your profile, or in the upper corner, there's like 3 dots, and you can identify yourself as who you are. But at the moment, we have a note here from Raphael. In the spirit of open source, will improvements be contributed back to Phoronix? I was curious if what's the case there, guys?
I would say, why not? I mean, the tool is to be planned to be released as open source anyways. So it might be a good option to contribute those back, especially because it makes maintenance of the tool in the future a bit easier. Yeah, so that's definitely an option which makes maintenance easier and would give back to the open source community. Yeah, we profited a lot from the open source community, so it's only fair if we give something back. So yeah, good point.
Thank you. Next question from Peggy Tang. Can the worklets be run separately? Can you address it?
Yes, they can be run separately. I think we can show this, or we will anyways show this during the live demonstration. So you will see that in a few minutes how that is done.
Super. And the next question from Ted Eckert. The efficiency of code can depend on the efficiency of the compiler. Have you verified that the compilers for the different operating systems are optimized?
Yes, good question. This is actually perfectly true. So the compiler plays a big role, and the compilation process of the software plays a big role. So our worklets basically are a mix of precompiled software, like for example, LibreOffice or Firefox or GIMP. This software basically comes as it is from the corresponding open source project. So it will have the same performance as when a user actually installs this software. And then there are other worklets which are actually compiled at installation time of the worklet. So it will use whatever compiler is present on your system. In the case of Windows, it will use GCC, which is installed with the Cygwin distribution. And yeah, that should provide decent performance. Anyways, it's the same as we software developers would do on those systems. So we think that this is representing the real world.
Great, great. And last question here from Steve Eastman. Steve wanted to know, will you be providing the list of worklets that do and don't work right now on Chrome OS? This will help industry worklet evaluation. Could you respond to that, please?
Currently, we don't have the full list ready to share, let's say. But we think that we will do more experiments on Chrome OS in the upcoming weeks. So this shouldn't be a problem to get some concrete test results for Chrome OS then.
Perfect. Okay, great. Let's move on to stay on schedule. Can you guys? I will keep monitoring the Q&A session. If other questions come up, please post them. And I'll hand back to you guys to continue with the test setup and procedure. Thanks.
Okay, so yeah, I will briefly explain you through this slide the test setup. As you can see, it's relatively simple. You don't need much equipment. What you need, and very important, is a regulated power supply. So we want to have a stable voltage as an input to our unit under test. So this is why it is important that the power supply is regulated, but I'm pretty sure that in your labs, you already have regulated power supplies. We need a measurement adapter. This is, let's say, not standardized. There are many of them. It's just a device in which you have to plug your unit under test, and then has to be connected to your regular power supply, so that your unit under test takes the power from your power supply, and on the other side, through a voltage and current connection, you can get the power demanded by your unit under test on the power meter. So it will allow the power meter to get the measurements, or to get the power measurement of the power demanded by the unit under test. Of course, you need both computers, the unit under test, the computer you are testing, and what I explained you some minutes ago, a controller computer. As you can see, the unit under test and the controller computer, they are not connected between them. We don't want to have a connection between them. The controller computer is connected here with display a USB interface to the power meter. It could also be GPIB, but we've mainly done our development with the USB interface. So the controller computer is connected to the power meter. The unit under test is just plugged into this measurement adapter, which is connected to the regulated power supply. And of course, we need a USB key for two purposes. At the beginning, to install the software on both computers, and also to gather the measurement from the controller computer and copy them to the unit under test, so that the software can merge the results obtained on the unit under test with respect to the performance of its worklet and the power measurements that have been collected by the controller computer. So now I will try to connect. We have here in the meeting, in our meeting room, we have this tab for you to show you. So I will, one moment, connect the camera, and I will try to stop sharing the screen. So I hope I'm not sure if you can see the camera full screen, our camera, or
I think if you go to screen sharing again, you can do advanced and then share the camera via that. Then it should produce a bigger picture.
okay, let me check it. Oh, no,
that's the wrong camera.
Let me check again if I can share the other camera. Because we've connected an external camera. Well, I think at least you can see it small, but
I think it's possible if participants click in that window that you've created and go down to the word pin, it makes that image of the GTD Yon image at the center of the screen. So,
yeah.
so participants want to do that now. In the corner of the photograph where you see the Yokogawa meter, you can just click in those three dots in the upper right-hand corner and choose pin in the menu, and then you'll see it in full screen.
Okay.
Thank you.
Well, what I can see is that the image is flipped, is horizontally flipped. But well, okay, I think we don't have to spend more time on it because at least you can see that something is going on here. So yeah, just quickly, you can see we have the power meter. We have a computer in today's setup. We don't have the two computers. We have one single computer which is running two virtual machines. Okay, so this is not 100% exactly the same setup you showed in the picture, but it's almost the same. It will do it. In any case, you see we have power meter, computer. Here, the measurement, the adapter. So we plug the unit under test here. As you can see, it is connected to the back of the power meter via this black and red cable. And we also have here this USB cable, which is just connected to the computer acting as a controller computer. There is the USB key because I didn't told you it before, but the USB key, when we are executing the test software, has to be connected to the controller computer because all the measurements or the power measurements obtained from the power meter are directly copied into this USB key.
Yuan, could I just mention one thing very briefly? The you guys, just for participants' benefit, this is connected to mains power in Germany, and it looks pretty good. You guys are right at 230, but there will be some distortion and anomalies in the grid. For the actual test in a laboratory environment, you'd want to have a conditioned power supply to make sure you're getting clean sinusoidal at 230. Yeah.
Yeah, of course. Thanks, Mike. So I will share the presentation again because I have one more slide before the live. So I stopped the camera. Okay, so we have an additional slide to explain you which is the execution workflow of the test suite. I will go quickly. We have the two computers, the unit under test and the controller computer. We start recording power measurements on the control computer before we start running the first worklet. And okay, when we've done that, we start the execution of the test suite on the unit and the test. All the worklets are automatically run, so no user interaction is required. So since the beginning of the first worklet until the end of the last worklet, everything is automatic. There is some wait time before or between the execution of worklet. So one worklet ends, and then we wait some seconds until the next worklet starts. Once the last worklet has finished, we see a message, and then the user can manually stop the power gathering application in the controller computer. At the moment, as of today, the whole test suite takes between 6, 7, 8 hours. But we planning to make it shorter. Here in the screen, you can see 3 hours. This is our first, let's say, milestone. But playing with which worklet do we finally introduce in the final version of the test suite? How many times do we run them? We can just modify the total duration of the test suite execution. So once the measurements, when the recording of measurements has been stopped, then we move the USB key to the unit and the test, and then we merge all the results on both computers. This is also automatically done by the software, and it takes less than 1 minute. And just after that, we can just, you can, via the result viewer provided by the test suite or using the CSV file, then you can assess the obtained result. Okay, so now we can proceed to the live demo. So I hand over to Thomas.
Thanks, John.
I stop sharing. Okay.
Okay, so I will share on my screen, and so you should now see my controller computer.
Mm-hmm. Yeah.
So this is both those virtual machines, which Johan already mentioned, are plain Windows 10 installs with no additional software. You can see which one I'm currently using by the text in the top right. So we have the controller computer and then the unit under test, which looks basically the same right now, as there is nothing installed on those machines yet. So as a first step, you will have to install the software on the controller computer. So I will just go ahead and connect the USB stick to this virtual machine. We can see it popping up here in Windows Explorer. You can start the Windows controller executable file. It asks for administrator permissions to actually do the installation. For macOS and Linux, you would obviously choose the macOS X controller or Linux controller file to do that on those operating systems. Then you can see the graphical user interface popping up over here. It gives you a brief introduction, and it also tells you the IP address of the controller computer. You will need that for the time synchronization later on. But let's get started with the installation. So there is a button which reads install prerequisites, and you can click that to install the prerequisites. One important thing I have to do first is to connect the power meter to the virtual machine so that I can actually install the driver. So let's click install prerequisites. We can see there is a tool popping up for the driver installation. So you just have to choose the WT series as my power meter and just go install driver. And it will hopefully only take a minute to do that. An important point is that you only have to do this for USB connected power meters. So if you have a power meter which is using GPIB, like the Yokogawa WT3000 or the WT210, you can just close the static tool and don't use it at all. So let's wait a moment for the installation to finish. It tells us that it will take up to 5 minutes. Usually it doesn't take that long. And now it's done. It says the driver was installed successfully, which is great. And now we can also see the active driver is WinUSB, and we could reinstall it if necessary, but yeah, that's fine for us. So we can close that, and the installation process will continue. So you can see the status here. It says installing Phoronix Test Suite, which is dependency 3 or 4 of the controller software. So it will take another second. If you're impatient and you want to know what's happening, you can click the show detailed status information, and you get a lot of output, which tells you exactly what is going on in the background. You can see there's now the dependency of PHP installed, which is the C++ redistributables. And then it will start and configure the Phoronix Test Suite. You can see it here in the detailed output. And then it will tell us that the task finished successfully. And that's basically it. The software on the controller is installed. If we want, we can check if the power meter is actually recognized. So we can click or choose our power meter model first, but the correct one is already selected for me. And then check connection to power meter. It'll take a second, and then a message will come up and say, yeah, if the device was found, it's a Yokogawa WT310. It tells us the firmware version, the serial number, and all the supported data, which can be read from that power meter. So we can just click OK, and then go on with the unit under test. So we close that as well. Then we check the USB stick. And switch over to the unit under test. Again, I will connect the USB stick. And this time I will start the Windows UUT install executable. Again, it needs administrator privileges to do the installation. Here, the graphical user interface is split in 2 versions. So for the installation or for the initial setup, you only have the installation commands available. This will then copy all the data to the computer, and afterwards you have to remove the USB key, but we will see that in a minute. Again, you can click show detailed information if you were interested in that, and then just go install prerequisites. You can see the status right here. It tells you what it's currently installing and yeah, how many is left. So we are actually at the second dependency now, which is Chrome, and you can see the Windows installer window popping up and doing the installation. The installation is completely automated, so you don't have to click through any install wizards or whatever, or do any manual intervention. It's just, yeah, it takes a few minutes to get everything installed, and once it's finished, you will get a notification. For the live demo, of course, the installation takes a bit too long, and I don't want to make you sit through all of this installation. So I have prepared a snapshot of this virtual machine, which already has the installation finished. And I will just start that one now, and we can see Chrome is installed. It popped up here on the desktop, and yeah, it continues now with Firefox. But I will just close the virtual machine and power it off, and then switch to that other snapshot and start it up. It should hopefully only take a few seconds. Okay, there we are. the installation is done. We get a message which tells us that everything was fine, task finished successfully, so we can click OK and continue. We can see that we have a lot of desktop icons now here on the desktop for some of the software that was installed. And most importantly, we have this folder called Energy Efficiency Testing, which contains the software to control the test run and to continue. The graphical user interface for the installation can then be closed, and we can disconnect the USB stick. I think VirtualBox did that already for me when I restored the snapshot. Okay, then we can open the folder it created for us here on the desktop. We now have a Windows unit under test run executable here, which we can start. Again, it needs administrator permissions, and we'll start up in a second. Here we are. So on the UUT, you have 3 text boxes where you can enter something or where you have to enter something. So you can name your test configuration, like my laptop. You can give a description, test during webinar, and then you need the IP address. Okay. I think I already saw a question regarding the time synchronization in the Q&A, so this is now the correct point to address it. So hopefully this question will be answered in the next minute. For the NTP clock synchronization, you obviously need a network between the unit under test and the controller computer. This is only necessary for the time synchronization, so you can basically disconnect the network afterwards. Alternatively, if that is too complicated, you could just do it manually by hand. So just open the clock settings and type in the time from the controller computer and hit enter in the correct second to set the time. If for whatever reason network setup is not possible or too complicated, even manually would be fine. But we think that in most labs, a local network connection shouldn't be a big problem. So to do the time synchronization, I have set up a network between those 2 virtual machines. There's nothing else on the network, so those virtual machines cannot connect to the internet or to my host computer or to anything else. So you can be sure that the time synchronization works with only those 2 computers without any additional access to the internet or whatever. So on the controller, I have now connected the USB stick again, and we'll start the controller executable. And yeah, once it pops up, we already did the installation, so we don't have to care about that anymore. We can now start the NTP time server just by clicking Start Time Server. It will ask us for a firewall exception, so make sure that you check all the boxes to allow it to communicate on all networks, and then click Allow Access. We can also see in the detailed status output, there is some debug information which indicates that the NTP server is listening on all interfaces. And we can go back to the UUT to then synchronize the clock. By the way, you can probably see that the time here in this virtual machine is not correct. So it's currently yesterday evening, according to the clock in this virtual machine. For this to work, I disabled the automatic clock synchronization, which is usually done by this virtual machine software, so that we can actually use this synchronization feature of our software. So what you do is you remember the IP address on the controller computer, and you type it in over here in the text box. And then you can click synchronize clock, which should again ask for permission to communicate on the network. Make again sure to check all the boxes and allow access through the firewall. And we can see the clock synchronization was successful, and it reports a accuracy of 0.00 something seconds. And we can also see down in the corner here, we have now the correct time. So almost 16 o'clock and 20th of January, which is correct. So we can click on OK here. So basically, we are now ready to start a test. So what we have to do before running any worklets is to start the acquisition of the power meter data. So we go to the controller computer and click Start Acquiring Power Measurements. And it will tell us, starting data acquisition and status is working. And you can see on the USB stick, there's a file created called syspower.csv, which will then contain your power measurements. If I update the Windows Explorer, you can see it's already grown to 7 kilobytes. So there is data going into that file. So everything should be hopefully fine. We can start to configure and then run our test on the UET. Usually you can just go run full test when you want to run all worklets in the configuration which they are intended to be run. Of course, this would take way too long for the presentation today. So you can click on configure worklets, and then you get in an array of checkboxes where you can disable the worklets you don't want. So I will just go deselect all and then check the GIMP and the LibreOffice worklets, because I think they are quite interesting to look at. And I will set the number of worklet repetitions to 2. One important point of the test tool is that it will automatically determine how often a worklet should be repeated. This obviously takes time, and especially in the virtual machine, because other stuff is going on the computer, would repeat the worklet quite often. So I will set it to just 2 repetitions so that we can finish in time. We can close that with the OK button, and then maybe show the detailed status information, and then just to run full test. And we can see that the test starts up. It will start the Phoronix test suite, evaluate all the configuration variables which are passed in, for example, which worklets should be run and which should be skipped. So you can see that there are a lot of messages that worklets will be skipped because I deselected them. Also, Phoronix test suite will start to collect system information so that you can afterwards see what computer was actually used to run that test. So you will get information regarding the system memory, the storage space, the used processor. You can basically see it showing up here, the screen resolution, the amount of memory, disk space, the used operating system and version. And it will now start up with the test. So LibreOffice GTD is the first worklet which is run. We can see that it does test run 1 of 2, and it estimates for 2 test runs. Yeah, this is what we have set. And hopefully we should see LibreOffice popping up in a second and doing something. Yeah, there it is in the background. It is actually quite slow, as you can see. So usually this runs way faster, but it's of course because it's running in the virtual machine with the controller computer running on the same computer and the video streaming going on at the same time. So obviously this setup I have here for the demonstration is not how you should do it in real life, but for showing it for the demonstration purpose. it should hopefully be fine. Every test run of the worklet for the LibreOffice worklet will create 20 documents. So they, you will see them popping up in the background. You can see there are several columns of numbers inserted and some formatting being done, and a graph created, which is then modified several times. It will also copy a worksheet. So if you look closely here at the bottom, you can see that there are new sheets popping up. So this is basically the LibreOffice benchmark, which we have created. I picked this worklet because I think it's quite interesting that you can actually see what it's doing without having to investigate into the code of the worklet. So most of the other worklets actually run in the background and you can see nothing at all. You only see the log output, which is not that interesting actually. But for demonstration purposes, I think it's quite nice to have those worklets which actually produce some visual output.
We haven't told you before, but there is a user manual in which we detail everything. So everything you are seeing here, we are explaining today, it's perfectly detailed in a user manual that is provided with the test suite.
Yeah, that's a good hint. I could also elaborate a bit on that. The user manual will contain a lot of information. For example, how to create a USB stick in the first place, which is of course necessary because otherwise you can't even start installing the software. The user manual does also contain then all the instructions to install and start the software and also to set up the hardware. So how to connect your power meter, how to set up your power meter, voltage and current ranges and so on. And the test procedure, I think it also then contains information regarding the test result viewer to see for you how it looks like. We will see it later on, but the test procedure also provides that. Unfortunately, the test is taking quite long, actually longer than I expected. So I should have probably done only one run per worklet. But I think the GIMP worklet should run faster because that one only does one image creation and not 20 repetitions. So it should hopefully finish within a few minutes. Maybe we can.
I can ask you some. Yeah, I was thinking we could use this time to ask a few questions. I just had a question on the time syncing. Are the computers connected to a network in order to synchronize, like Ethernet or Wi-Fi? How does it actually? Because I missed that in the procedure. How do you get the UUT synchronized with the controller computer?
As I explained already, the synchronization of course needs a network connection if you want to use that synchronization feature of our software. It is actually recommended in the test procedure that you disable the network connections once you have synchronized the time, because we have seen that having basically anything connected to the computer does actually increase power consumption. So if you have a USB device connected or if you have a network connection, doesn't matter if it's Ethernet or wireless or whatever, it will increase power consumption. And of course, you don't want that for your new PC. You want to have the best energy consumption possible and the best circumstances for your system.
Great, thank you. Next question, one of the colleagues asked here, to make sure that the standard unmodified worklets are run for submitting results, is some kind of checksum included in the results?
Yeah, that's an interesting point. Currently, we don't have any measurements or any things in place to verify that the correct worklets are run in an unmodified way. I think you could always circumvent such things. So if you want to trick the test suite into running something else, you could always do that. So I think it doesn't provide any real evidence, but it's an interesting point which probably needs to be discussed. Maybe we can also learn something from other benchmarks, like the CERT benchmark for servers. Maybe it would be a good idea to look what they do, or if they do something in that regard.
Mm-hmm. And it could also be, if there's any market surveillance authorities on the call today, if they're running tests, they would obviously be using unmodified worklets. And then they may find a disagreement between the submitted results and their tested results.
Yes, exactly. So yeah, it might happen like with the cars we had in the last few years, that it was turning out that manufacturers of cars actually tune their engines to recognize test cycles. So maybe something like that could happen with those worklets too.
And I'm not sure if this has been answered already. I just asked John if he, Sundragon Waits asked if NTP is involved, presumably so controller and UUT have the same time, so collected power measurements can be correlated with worklet time spans. But how does UUT get time sync without network connection, at least peer-to-peer to controller? So I think you've answered that now.
Yeah, I think that's answered. Yeah, there is a peer-to-peer network connection. So that's necessary. Otherwise, it doesn't make sense.
And then switched off before you start the test.
Yeah.
Yeah. Okay. Great. It looks like you may be ready here on your
Okay.
screen.
Yeah, the test is finished. So we get a message now which tells us to insert the USB key with the power measurements. So we can now go back to the controller computer, then click on stop acquiring power measurements. It will tell us the measurement is complete. So no errors there. Great. We can close out the controller software and then just disconnect the USB stick from the virtual machine. Okay, device is in use. Let's close Windows Explorer and try again. Okay, I will just disconnect it from the computer directly, but I would actually recommend to eject it properly, because otherwise you might end up with an incomplete power measurements file. I think we had that in the past. I hope it will work now. No idea why it was reporting that the USB stick is still used, but let's see. So I connect the USB stick again to the unit under test. And we do have the syspower file right here. So we can click on continue. And it will take a second to merge those results, and then it will copy the test results to our folder here on the desktop. And it tells us the task has finished successfully. So we can now also close out the unit under test software. Here on the folder on our desktop, we got a new folder called test results. And if we open that, we can see the results which we just created right now. So I will go ahead and grab that folder and then copy it to the USB stick so that we can analyze it on the controller computer or on any other computer you like. So copying has finished. Test results folder is right here. Okay, there are some other results as well in there. Doesn't matter. So I can go ahead and check it. And then go back to the controller computer. Connect the USB stick again. Yeah, now it failed to attach. Okay, that's the fun of live demonstrations. You never know when something doesn't work as you intended to do it. Ah, it's still connected here. Okay, disconnected from the UUT. Connected to the controller computer. And we can start the controller software again to be able to access the result viewer. So this time we can click Open Result Viewer, and it should hopefully pop up in the default browser. Seems to be working. So we can see all the results I have in the result directory on my USB stick. So the top one is the one we just created. You can see the date, 20th of January, and the time. So we can open that up. And now we get all the results. We can see our system information in the top here. So we can see, yeah, it was Intel Core i7 processor running in Oracle VirtualBox with 4 GB of memory, 100 GB of hard drive, Windows 10 with the build number. So you see exactly which version of Windows 10 you're running, screen resolution, and then we get a list of worklets which have been run. So there is the LibreOffice and the GIMP worklet as expected. Those numbers here are only performance, so keep that in mind. You have the unit here, so you can see both are in seconds, and arrow means that the result is lower is better, so less seconds is better. And it also calculates a geometric mean. That is, of course, also only for the performance values here. So keep that in mind. We then get the detailed results for each of the worklets. So we have 3 buttons here, or tabs. You can see the performance. So one run of or one document created by the LibreOffice worklet took 7 seconds. You can see the standard error, and you can see the number of repetitions of the worklet done here. You can then switch to the system power demand. This is the data recorded by the power meter during that worklet. So you can see power consumption was around 33 watt throughout the whole worklet. As I would have expected, the power measurements are probably not that useful in this setup because, as I said, we're running in a virtual machine and running several things on the same computer, which obviously increases power consumption by a lot. So we cannot rely on those numbers, but we can see that the data has been acquired from the power meter. And finally, we can switch here to system power per performance, or efficiency, in other words. And you can see the performance per watts, which is 40 watts, 40 performance per watt. Yeah. And we can also see the same for the GIMP worklet. It's basically exactly the same. We again have a result of 67 seconds per test try. We get the power results here. One thing which is quite characteristic for the GIMP worklet is that the first run, you can see it here as try 1 in the red color, takes quite a bit longer than all the subsequent runs. This is due to the fact that GIMP has to be loaded from the hard disk, and on first run does enumerate all its files and plugins and so on. So a further modification of this worklet will probably skip this first run because it's not the real world performance, because usually you don't reinstall GIMP every time you use it. And again, we can see the efficiency, which is here at 4.62 for GIMP. We can then see the system power demand monitor, which is the data acquired from the power meter throughout the whole test run. So we can see if there is any big change in power consumption. Usually for the more compute heavy worklets, you can actually see them quite nicely in this plot, and you can also see the repetitions of this worklet. There is one thing which should actually be in here, which is not there, which is the meta efficiency. This would be the combined metric for all the worklets. I think it's because we only ran 2 worklets, so it will not calculate that for us. But if we run a bigger set of worklets, it will also calculate the meta efficiency value to average out, or it's actually a geometric mean for all of the worklets. If we have time, in the end, we can take a look at some other results where you can see it, but I think we don't have the time, so we will probably do that in the next webinar in 2 weeks. Okay, now I will go back to the presentation. Or are there any questions that's maybe to discuss first?
Yep, we have 3 questions in the parking lot, and I've told the folks who asked them we're going to address those at the end, because they're more sort of in-depth questions about the run times and getting different results when testing the same UUT. However, there is a question here from Noel Scott about what you were just discussing, Thomas. Geometric mean number for the 2 benchmarks does not seem correct. Why? I think he's asking about what you just showed. The geometric mean was not correct.
Yeah, you're right. Yeah, if one measurement is 7.1 and the other is 67, the geometric mean should be between those 2 values and not lower than both. So there is something strange happening. Yeah, I can't explain it right now. Maybe it's due to the fact that only 2 worklets have been run and it wasn't repeated enough. Yeah, I'm not sure actually, but yes, that's correct. The value doesn't make sense.
We'll get back to you on that, Noel. Thank you.
Yeah, we will investigate what's the problem here.
Okay. And that's the other 3 questions I want to save till the end, so you can continue.
Okay, then we will just continue with the presentation. There are 2 pictures in the presentation in case you want to take a look at the setup again, which we showed before. So for the last chapter of this presentation, we want to give you a bit of an more detailed explanation what the worklets actually are, and a bit of an explanation what they do and how they represent the results. So we have for each of the worklets or the worklet groups, let's say, a few information prepared. But first, we want to dive into the things that make out the worklets or our requirements, which we had to select those worklets. So basically, when we started this activity, we wanted to reuse as much as possible existing software to be actually relevant for a real-world use case, because when you only run synthetic benchmarks, which you have just invented, you have no idea whether this is actually relevant, and you would need a lot of test data. So to speed up that process a bit, we decided to use existing benchmark software and existing real-world applications. You have seen that in the live demo. There is, for example, GIMP, LibreOffice, Blender, and Firefox and Chrome, and several other things we will see when we come to the list of worklets. One of our goals is obviously to test all relevant use cases for a computer, so it should represent all users and all use cases. But still, we want to maintain a simple test setup So for example, there should be no complicated network setup or any worklet which might stream data from the internet or download something from the internet, because that is just too unreliable, and we don't want that the efficiency of the computer depends on the speed of the network connection to the internet or something like that. So there is no worklet which does stream videos from YouTube, for example, because that just wouldn't work out reliably. Additionally, as Johan pointed out in the beginning of the presentation, it was quite important to us to have an open architecture for the framework and for the worklets, so that we can actually control everything and modify it to our needs, and also that you are able to re-verify that and to look into those worklets and to understand what they are doing, and to assess them in a proper way. This wouldn't be possible with closed source worklets. So we have defined a few criteria for existing worklets. They should be supported on all relevant operating systems. So currently we have support for Windows, Mac OS X, and Linux, with Chrome OS and support for the Apple ARM M1 Mac machines, which are coming up now in the works. So all the software should be free and open source, as I said. If possible, the worklets should be actively maintained so that we have a chance of getting bug fixes and future improvements basically for free. They should simulate a workload of a typical user, so it should be relevant to the real world. The worklets should be suitable for automation, so that the test can actually run without human intervention. And they shouldn't require any special test setup just for one single worklet, just to keep everything consistent. From the worklets we have selected, we have done quite some changes to those worklets. So for example, we added support for missing operating systems, especially since Phoronix Test Suite is mostly used in Linux testing. There was sometimes support for Mac OS X and Windows missing. So we added that as far as the software which does the actual test is available for those software. We created the missing automation around this software. We worked to allow the worklets to be run in offline mode. So we, for example, we have a browser worklet which tests browser performance. This had to be adapted to not rely on resources downloaded from the internet. And we include as many dependencies as possible for offline installation. So for Windows systems, which is the majority, I think, you can actually run the installation completely offline without ever being connected to the internet. Then the installation of the worklets should be automated as much as possible. You have seen that in the live demonstration, so the installation runs without any further user interaction. And obviously, we had to check that all the worklets run on all the expected computer configurations, so it should work on a low-end computer and on a high-end computer. So for example, an Office PC, which uses a subset of worklets, should also be able to run this subset of worklets, even if it's a low-end computer. So we will now go through the list of worklets so that you can get an idea of what's going on. We have one worklet, it's called prime sieve, which is basically for number crunching. So it calculates prime numbers and gives you a result in seconds for generating those prime numbers. I think this is one of the worklets which is not very user focused. So usually users will probably not generate millions of prime numbers, but it's an interesting workload for a CPU, and just to get the raw performance of the CPU, of the integer units of the CPU. We have then quite a few rendering benchmarks. There is AO bench, which is AO stands for ambient occlusion. So basically tests floating point performance. And there is C-Ray, which is a ray tracing renderer, also for CPU performance. Both of these rendering techniques are used in real-world software, like for example in games or in 3D modeling and rendering. So we think that those worklets actually have some real-world application. The result is given in seconds needed for a certain rendering for both of them. We have two more rendering worklets, which are Blender and Appleseed. Those are both real-world softwares, which you can use throughout your day-to-day work if you have the correct job. Blender is very popular in 3D modeling and can also do video editing. It can render on the CPU only or via the graphics card, via OpenCL or CUDA, and gives you the result in seconds for a certain rendering. There are actually different models available, so there are a lot of options with the Blender worklet. Appleseed is also a similar rendering. It's focused on illumination, so that's a bit of a different purpose maybe than Blender. Again, it has different scenes available, so lots of options here, and gives you also the result in seconds for the rendering. Then we have compression and decompression worklets. There are actually quite some of them. They are all more or less similar, but they are easy available, so we chose to take them in just to see if it makes any difference between those. So we have 7-zip. We have the XZ compression tool, which is basically a different algorithm. The difference between those worklets is that they give you results in different units. So we have a million instructions per second with the 7-zip worklet, and the results in seconds for the XZ compression worklet. And then we have one more compression worklet, which uses the Z standard algorithm. This time it gives you results in megabytes per second. And then we have one decompression worklet, which uses the 7-zip algorithm. It is quite interesting here that it also, because it also tests the storage performance of the system, not only CPU, which is especially on Windows quite interesting in test results, because Windows seems to lag a bit behind in these types of workloads. We have then one workload for computer-aided design and one workload for photo editing. So for CAD workloads, we have FreeCAD. This uses the FreeCAD version you can download from the internet. So it's an unmodified version, and we have written an automation script for FreeCAD to create a 3D model, and we measure the time in seconds needed for that 3D model to be created. For GIMP, which you have actually seen in the demonstration, we did a comparable thing. So it again uses the unmodified version of GIMP and creates an image via the application interface via a automation script. We have a few worklets for office tasks. They are implemented using LibreOffice. So the LibreOffice Office suite, which is quite comparable to Microsoft Office, but open source and available for free. One workload is converting PDF documents or LibreOffice documents to PDF documents. Gives you the result in seconds needed for converting 20 documents. And there is the LibreOffice spreadsheet worklet, which you have seen during the demonstration. And it creates a spreadsheet with various numbers and a graph. And it uses the LibreOffice UNO API to do that. That could also be extended. Of course, this API does have a lot more features which we haven't tapped yet. So that could be also interesting to improve on that, and maybe not only use the spreadsheet processor, but maybe different parts of LibreOffice, like the presentation module or something like that. Then we have one worklet for web browsing, which is based on Selenium. Selenium is a browser automation tool which you usually use to test your websites if you develop websites, but it can also be used for our purpose. So we automate Firefox and Google Chrome to run the Kraken benchmark, which is a JavaScript benchmark, and it gives you a result in milliseconds for an average benchmark task. We also do have an idle worklet. As you know, we are developing this software tool to replace previously existing benchmarks which only use idle power consumption. But still, we think that idle power consumption is an important metric, so we don't want to remove that completely. That's why we have an idle worklet. So it does nothing basically for 10 minutes and measures the power consumption during that time. We then have one worklet for cryptography. So it uses the OpenSSL library to create cryptographical signatures. So this is quite a usual workload. When you're browsing the internet, you are doing cryptography all the time. If you're writing emails, you're doing cryptography all the time. So that's quite an important workload. And it gives you as a result the signs per second, or the cryptographical signatures created per second. Then we have a worklet for storage, which is based on the I/O zone test. It measures read and write performance of your storage, your hard drive or your solid state disk. It can be configured quite flexibly to test reads and writes and with different file sizes, and gives you a result in megabytes per second. There are two worklets for memory tasks. So there is the t-test, which implements a custom memory allocation algorithm and does a predefined set of allocations and measures the time. You can configure the number of threads to use, so it can also make use of multi-core processors here. The cache bench worklet is a bit different, as it also focuses on the CPU caches, and yeah, similar to the I/O zone worklet, it can do reading, writing, and also read, modify, write cycles, and gives you a result in megabytes per second. Then we have two worklets for image and video processing. The image processing worklet is based on TJBench or libjpeg turbo, which is a JPEG compression and decompression benchmark. And it gives you a result in megapixels per second. And we do have an X264 worklet, which does video encoding with the X264 codec. So it basically encodes an example video and measures the frames per second the machine can encode. We have one worklet for database workloads, which is based on the SQLite implementation of a database. This is also quite relevant for day-to-day usage because, for example, your web browser and your email program will most likely use SQLite databases in the background. So this is especially for office use and yeah, all the web browsing, quite an important software. It basically executes a defined set of queries against the database to first create a database and then retrieve some data from the database again, and it measures the results, the time in seconds it needs for those queries. There is one worklet based on OSBench, which does test various low-level functions of operating systems. That is, for example, process creation, thread creation, file creation, memory allocations. And it gives you the results in microseconds per event. So, for example, how many microseconds it takes to create a process, or how many microseconds to create a thread, and so on. We have two worklets for various or popular programming languages. So there is PyBench for the Python programming language, and there is Takabo Bench for Java. So this will basically measure the time or the performance for applications written in those languages on that machine. Finally, we have a few worklets for gaming. There is the ParaView worklet, which is not strictly speaking a game, but we found that it does quite well as a proxy for gaming. So it's actually a data analytics tool, but the results are quite comparable to 3D games. And also it provides a result in frames per second, or alternatively, you can have a million voxels per second, which is maybe not that relevant anymore as a metric. We have Open Arena, which is a open source 3D shooter game. Unfortunately, this one doesn't work on Mac OS X, so we will probably not use it any further. Then we have Xonotic, which is another open source shooter game. This one does work on all platforms, so it's the better choice. And what it does is that there are predefined character movements in the game, and those are executed. Yeah, it's a scripted run of this game, which and the computer is measuring how many frames per second it can render during this test run. For comparison purposes, we have the Unigine, Heaven Valley, and Superposition worklets. They are quite nice 3D benchmarks, but unfortunately they are not open source. So yeah, we can only use them for comparison and probably not in the final version. Okay, that's so far the list of worklets. Finally, we want to do a comparison to other industry standard benchmarks, just to give you an idea of what is already on the market and why we didn't select it. So first, I want to start with Sysmark. Sysmark, as far as I know, so all this information is taken from the marketing material of Sysmark. It uses some unmodified real-world applications, just in the same way as our worklets do. It has different scenarios for usage profiles like office or gaming, which is also what we are working on. But it doesn't have gaming, the next bullet point says. So yeah, it's office and productivity mainly. The approximate runtime is around 1 hour. So that's something we have in mind too, that we need to speed up our test suite, which currently runs around 6 to 7 hours in the version available. It does actually measure energy consumption, but it doesn't give you an explicit efficiency metric. So you cannot use Sysmark for efficiency metrics without additional steps. And one problem we have seen, or which we think is a problem, is that it only supports one single power meter, which you can buy nowhere anymore because it's quite old. And it also doesn't support 230 volts, so you cannot use it in Europe, which makes the test quite unusable for us. Sysmark is a proprietary test framework, and also the worklets are proprietary, so you cannot investigate it or change it in any way. And it also does only support Windows. We have one screenshot of Sysmark 2018. The user interface for Sysmark 25, which is the newer version, is actually quite similar. So basically it gives you an overall rating, gives you productivity, creativity, and responsiveness scores, and also tells you the energy in watt hours. I think during this test run, the energy was not measured, so it's not shown here. As a second benchmark, there is PCMark on the market. It does use also real-world applications, but also synthetic benchmarks. It has different scenarios for different usage profiles, so that is fine. It's focused on office and productivity workloads, and there is a gaming workload in an extended version, which you have to buy extra. The approximate runtime for this is around 30 minutes for this extended version. It does have an interesting profile to measure battery life, but this alone is also not energy efficiency, because battery life obviously does depend on the size of the battery as well as on the efficiency. So you would have to do other calculations as well. You don't get an efficiency metric by default from this software. Again, it's proprietary. You cannot change it in any way, and it only supports Windows. Here's a screenshot. You get basically one big number with your PC mark score, and then you get a few sub-scores for essentials, productivity, and digital content creation, which give you a hint what that computer might be good for. As a last benchmark, we have looked at Geekbench. As far as I can tell, it doesn't use any real-world applications, but it claims to be simulating common tasks like email writing or browsing or extracting files or whatever. But it doesn't directly rely on any open source or otherwise available software. As far as I can tell, it doesn't have different scenarios, so there is only a single core and a multi-core result. It does not measure energy consumption at all. It's proprietary again, but this time it at least supports Windows, Mac OS X, Linux, and even mobile systems like Android and iOS. That is quite nice, but yeah, as it's proprietary, it doesn't make a lot of sense to use for our purpose, and we cannot extend it with power measurements, for example. Here we have a screenshot of Geekbench. Yeah, you can see the single core score and the multi-core score, and some information to the system under test, which is what you get from Geekbench. Finally, I want to announce that we have created a website with the software shown in the live demonstration, so you can actually access it and use it for yourself. We also have the test procedure on that website, and we will also post the slides we have shown throughout this webinar on this website. And I think there will also be a recording of this webinar, which will then also be available on this website in the next couple of hours or days.
Thomas, I wasn't, I'm sorry, it's my fault. I didn't know you were going to announce this just yet. I've been telling folks that we would launch it tomorrow or Friday.
Okay.
I was thinking, don't we need to update the software manual? Because the version that we have right now was for the July edition of the tool. And I think we've made some changes based on the feedback from Digital Europe members. So we probably need to make a couple small changes to the software manual for this version.
Okay, I think the most changes should already be in there, like for example with the time synchronization.
Okay.
So I think you should actually be able to run it with the test procedure as it is on the website, but we will take a look again and make sure that it's actually the correct one with all the necessary information.
Great. So folks, please do feel free to check the website today, but officially, when you get an email from Paulo or ourselves with the link, that's when everything will be checked and verified. So and it does include the slides, as Thomas was saying, the slides from last week's presentations on the 13th of January, where the Commission was running the 3-hour webinar, as well as today's. And we will use the same page for the presentation on February 3rd in 2 weeks' time. Great. Thomas, I'm sorry to interrupt you there. Just did you have more to say?
No problem, Mike. I was actually finished. So this is my last slide. So
Super.
You can go ahead if there are any questions. We can discuss those.
Yeah, so I have one question which is relevant to what you were just presenting. Thomas Eckert is asking, will there be support for Windows on ARM devices, ARM devices?
Okay, that's a good question. Currently, we don't have any Windows ARM devices, so we don't plan to do anything in that regard. We also think that the market share of those devices is quite minimal, so it's probably not relevant, at least for the current stage of the software.
Okay. And this going back to the top of the list, Shahid asked, Shahid from Intel, it says in your slides, it said 3 hours to run the test. He wanted to check, is this a new version of the test? The latest version of the software? Did you reduce the number of worklets that were included?
Currently, the software still has all the worklets, so it's 6 or 7 hours run, which yeah, we had in the last couple of months with Digital Europe. But yeah, the 3 hours is our short-term goal, let's say, to reduce it to that amount, but this will be a future version.
Okay, so you haven't made the determination which of the worklets you're going to remove to get down to 3 hours?
Yes, correct.
It's still being studied. Okay, okay. Thanks for that. Ian Lee asked a question. He said, and we may need to unmute him, Jenny, to get him to respond. Ian asked, we tested the same UUT several times and got different results. How do we determine which result should be adopted? Brackets, the highest, question mark?
Mm-hmm. This can have several reasons. Obviously, it would be great to get the same results again. So it would probably be interesting to find out why the results are different in the first place. I can think of several reasons why this could be the case. For example, you can have an operating system update in the meantime between your runs, or yeah, you can change something about your UUT, like any settings. Like for example, the power plan on laptops is quite important to be set the same way, or you can, yeah, if your operating system just decides to do something in the background, like yeah, installing updates, defragmenting the hard drive or whatever, this might cause some issues. So in that case, it would be interesting to see what the reason is, or if it can be found out what the reason is. But I think for, yeah, if this actually happens in the real world, there needs to be some policy how to act on those results. But I think we are not in the current state to determine this. So this has to be, yeah, decided at some later point.
Yeah, but in any case, I would like to add, you will never have perfectly exactly same efficiency value on several runs of the software. They will always slightly differ. We cannot control 100% what the operating system does in the background while you are running the test. So it's very difficult, if not impossible, that you get exactly the same efficiency result in successive runs of the test suite. So it is expected that we have very small differences. Then, of course, as Thomas said, if you run the test suite several times, it has to be decided which value at the end is adopted, the higher, the average, or maybe we tell the company to run the test suite only once. This has to be yet decided. Yeah. But just Ian, just one thing, yeah, we don't have your numbers here, so yeah, you say tested it and several times got different results. If the difference between the values you got is very small, decimal, it is normal and it is expected.
Yeah, I think a few percent of deviation will not make a difference in any energy class in the end. So if you only have a few percent of difference, then that's perfectly fine.
If you wanted to share your data, Ian, with the team, we'd be happy to look at that incidence of difference and maybe help you identify the problem. Just a quick question I tried to answer, guys, in the chat. Noel Scott asked me, or asked us if the the WT210, the Yokogawa, the old Yokogawa, is compatible with the GPIB, and I said, yes, it is, but I believe you have to be running Windows on your controller computer because the software for the GPIB is only written for Windows. Is that correct?
Yes, that's absolutely correct. So the WT210 is supported via GPIB on Windows. Yeah.
Yeah, and the same with the WT3000. If you happen to have that, that's also a GPIB power meter.
Yes.
Okay, great. We're getting a few more questions coming in. Steve Fernandez from Intertech just asked, I think this is in response to Ian Lee's question, I thought the worklets repeat themselves until there is sufficient stability in the runs.
Yes, this is actually what the test suite does to ensure that the worklets are reproducible. So this is one of the measures to assure that the worklets are reproducible. So again, it would be interesting to see what happened and how big the difference between the different test results is in Ian's case. So because basically it shouldn't happen because the worklets are repeated until consistent numbers are reached.
Steve asked a follow-on, could you clarify what discrepancy is considered within that stability? Like what is, do you know what the tolerance is on the reproducibility of the test?
This stability can be configured for each of the worklets. Yeah, it depends on the worklet, what the concrete numbers are.
Okay. Maybe when we look at this in more detail, Steve will make a note about that and see what the typical deviations are that we're seeing and what the software settings are. Paul Ford asked a question here. Do you have any data that shows how worklets scale with the addition of storage or memory?
We don't have any data regarding that, but Digital Europe provided, thankfully, some data on that point in the stakeholder meeting. So maybe it's interesting to look at that again. The slides are actually also posted to the website. I think they found that the efficiency score varies quite a bit depending on which components you put into your computer. Be it memory, different CPUs, different power supplies. So it makes a difference for the efficiency, which components are used.
Great. And I think this similar answer here to Noah's question, Noah Horowitz from NRDC is asking, do you have any power use test data that compares the power use from your worklet testing to the results from benchmarks like Sysmark or PCMark? Would be curious to see if they are relatively close or not.
Mm-hmm. That's an interesting point. I would be really interested in this data, but unfortunately I see not really a way how we could do such a test, because as I explained, those benchmarks like Sysmark and PCMark, they are all proprietary, so you cannot actually look into those and see what they are doing to replicate this as a worklet on our side. The comparison would always have a lot of guesses and probably be not representative, I guess.
And they don't offer the same output, is that correct, in terms of the efficiency score?
Yeah, they actually do not have an efficiency score at all. That's the main problem. So we would need to calculate an efficiency score by hand, similar to what Digital Europe did in the presentation for the stakeholder meeting, and then see if the relative difference between various PCs is more or less the same. That could be an option, but I think it's quite tedious to do. So we haven't looked into that yet, at least.
Okay. Paul Ford has just asked another question. Do any of the worklets emulate machine learning that use huge data sets?
No, there is currently no worklet for machine learning. We think that this is not really a use case a user will do on a office PC or on a budget laptop. So for your huge data sets for machine learning, you would probably use a workstation with multiple graphics cards and so on. And this is probably not the main focus of our benchmarking.
Great. And Noah just noted here, I was interested to start with just understanding the reported power. So, okay. I think that's in relation to Noah's question about Sysmark and PCMark. Are there any other questions, folks? We're just 3 minutes before our planned ending for this time, for this occasion. And we, as I mentioned, we will have a second, more in-depth training in 2 weeks' time on February 3rd. Jenny, you posted the hyperlink into the chat, didn't you? Oops. Maybe we can paste that in again for folks. Great, thanks, Jenny. So yeah, so the hyperlink is there. If you haven't already, please do register. And yeah, any of our questions, maybe the questions that we weren't able to answer today that we need to do a little bit of investigation on, we can address those at the start of the next time in 2 weeks. Thank you all so much for your participation, for the questions and the engagement. We really appreciate it. And a recording of this will be posted, as Thomas mentioned, on our team website. And we look forward to working with you moving forward. Thank you so much. Good evening, good afternoon.
Yeah, thank you.
Thank you. Bye-bye.
Bye-bye.